Let us look at proposition number 7 of book 4 of Euclid's Elements. The proposition talks of constructing or circumscribing a square on a given circle. So let's see how we can go about doing that. So first thing we do is we identify the center. You know how to do that? We take a random point on the circle, let's say A. We join these two to form a line and mark the intersection on the other side. And now, basically what we are trying to do is construct two diameters perpendicular to each other. Okay, so now we have to draw a perpendicular at E, perpendicular to AC. So we know how to do that. So let's very quickly do that. B and D, and let's join BD and AC so that we can hide the lines, and let's hide all the circles and irrelevant intersections. Okay, so now we have two perpendicular diameters. Now at A, we are going to draw a line perpendicular to AE. Basically, we are going to draw a tangent at A. We know how to do that again. For this, we require this line, intersection, circle, circle, line. Okay. Now let's hide all these. And similarly, without going through all the steps, let's draw a tangent at D, tangent at C, tangent at B. And let's mark the points of intersections of these lines, F, G, H, K. And let's join these points so that we can hide these lines. So we have constructed a square FGHK, circumscribing the circle. But it's not just enough to construct it. We should be able to prove that it is a square. Now to prove that it is a square, we have to show that GF is equal to FK is equal to KH is equal to BG. All the sides are equal. And the angles F, G, H, K are all right angled. So we have to show that these are all the sides are equilateral and equiangular, and more specifically right angled. Okay, so let's see. What do we have as of now? We know that angle GAE is 90 degree because this is a tangent to this radius at this point, to the circle, tangent to the circle at this point. It is perpendicular to AE, a line from the center. So that is 90 degree. We know this is 90 degree. Why? Because we created two diameters perpendicular to each other. That means angle AEB is 90 degree, and this is also a tangent being joined by a line BE from the center. So that means this angle is also 90 degree. Angle EBG is also 90 degree. Now if you think about this, this is a line, this is another line, and this BE is the traversal through these two lines. Now the sum of the interior opposite angles, if it is 180 degree, then that means these two lines are parallel. Either we can think like that, or we know because this is a tangent, this angle will also be 90 degree. Angle HBE will also be 90 degree. That means alternate angles between these two lines and this as a traversal. So whichever we use, we end up with a statement that GB or GH is parallel to AC. So since this is parallel to AC, And similarly, we can prove that FK is parallel to AC. Since they both are parallel to AC, that means they are parallel to each other. That means GH is parallel to FK. Now, similarly, look at GF and BD. These are two lines. Traversal is AE and the interior opposite angles sum up to 180 degree. These two lines are parallel. Similarly, these two lines are parallel. And since GF and HK are parallel to BD, that means they are parallel to each other. Now, again, whether you look at it from GF or BD point of view, or whether we look at AC point of view, we end up with the statement that each of these is a parallelogram, in which case all the opposite sides are equal. Since these are parallelograms, whether we look at it horizontally or vertically, all the sides are equal. So that means GH is equal to AC equal to FK. GF is equal to BD is equal to HK. So all the sides are equal to each other. Now, remember, in a quadrilateral, diagonally opposite angles sum up to 180 degree. This is 90 degree. That means this is also going to be 90 degree. So angle BGA is 90 degree. Now let me mark all the other angles as well. EAF is 90 degree. 90, 90, 90, 90. So first we take up just GBEA and repeat that process for all the others. So we have a quadrilateral FGHK whose sides are equal to each other and the corner angles are all 90 degree. That means what? That it is a square. So we have constructed, or rather circumscribed, a square on a circle, and we have also proved that it is a square. So that is proposition number 7 of book 4 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can benefit from it, please do share it. That's it for now. Bye.